Welcome to video 2 of integration by parts. We're testing out this new technique of finding antiderivatives. In the last video, we did this UV substitution, and we said the answer was this. And I said, if you want to make sure we did this correctly, that means if I take the derivative of this green clouded expression, we should get back to where we started. So over the break here, I went ahead and took the derivative. So the derivative of this plus that means I'm taking the derivative of each of them separately since I'm adding. And when I take the derivative of the first thing, because I'm multiplying, I got to do the product rule. And so here's the product rule. You can double check that I do that correctly. But once I do the product rule, I notice that I have negative cosine x plus cosine x. These are actually going to cancel. The derivative of the constant was 0, so that's gone. And so I'm left with a negative sine x times a negative x, and that leads me to this, which was my integrand that I started with. Okay, so I just wanted to double check that we were making sure this UV substitution actually works. When I do this process based off of the product rule, I'm able to find the antiderivative. Again, I use this whenever I am multiplying functions because I cannot take the antiderivative of the first times the antiderivative of the second. You cannot do that. I'm actually going to skip number 2, and I'm going to go into the practice here. I think I'd like to do number 5. Now, number 5 offers us another twist, which is now we're finding the definite integral. So even after I find the antiderivative, I still need to evaluate that antiderivative at these limits of integration. Okay, but we'll begin a process. I need to identify u, and I need to identify a dv. And then that's going to give me a du, and that's going to give me a v. So when I look at this, here's an example of you have to kind of go through kind of the checklist, which one of these is easier to differentiate? Well, most people would say that's easier to differentiate, right? But if that's true, that means the other one has to be easier to anti-differentiate. And I don't know what the antiderivative of the natural log is, right? We know that the antiderivative of 1 over x is the natural log. But if the function is the natural log and I'm trying to anti-differentiate that, we don't know what that is. So maybe that's not the way to go. Maybe the way to go is take the derivative of the natural log and take the antiderivative of this. So because of that, I'm going to choose this to be ln of x, and I'm going to choose this to be x to the 4th. And actually, you know what? Let me change the colors so that they match what we were doing before. The natural log of x is my u, and then my du is x to the 4th dx. Why? Because finding the derivative of the natural log of x is easier than finding the antiderivative of the natural log of x. So this would be 1 over x dx. And then on this side, the antiderivative of x to the 4th, well, I'm supposed to add 1 to the exponent and divide by the new exponent. Great. So then according to what I have in my copper and my pink writing, the antiderivative of this would be, u times v, so it would be the natural log of x times x to the 5th over 5, minus the integral, if I'm going to use colors, let me continue the consistency of the colors here, minus the integral of v du, of v du. Now, even here, this is going to be not so bad of an antiderivative, and we'll see shortly. By the way, I still need to evaluate this between 1 and e to the 2nd. So here, this is going to be the natural log of x times x to the 5th over 5. And maybe I want to put that in the front. X to the 5th over 5 times the natural log of x minus. This 5 that I'm dividing by, I can pull that out and it becomes a 1/5, and that gets rid of this part, right? And then 1 over x times x to the 5th, that means this as a whole becomes x to the 4th. So then taking the antiderivative, that would be x to the 5 over 5. Oh, but don't forget, that was that 1/5 there. And then plus c. So I could reduce this and get x to the 4th, and then take the antiderivative. The 1/5 came from the fact that I was dividing by 5, so now I have to bring it back into the picture. So my final um, antiderivative, I guess if I want to clean it up, would be something that looks like this. Oh, but I need to evaluate that from 1 to e squared, which means I need to substitute those into my formula. So that's going to give me e squared to the 5th over 5 times the natural log of e squared minus e squared to the 5th over 25, and that'll be the first part. I guess you can put the plus c if you like, but it's about to be canceled out when I do the second part. And then 1 to the 5th over 5 natural log of 1 minus 1 to the 5th over 25 plus c. So remember, the first part of the fundamental theorem says if I want to find a definite integral value, take the antiderivative, substitute the top limit into the formula, substitute the bottom limit into the formula, and then subtract them. Alrighty. Well, let's see. This is e to the 10th over 5. Natural log of e to the 2nd, that's just 2, right? Because the natural log and the e cancel each other out, and I'm just left with 2. Minus e to the 10th over 25th. The c's and the minus c's, those are going to cancel out, so I'm not too worried about those. Those are gone. Minus, let's go back to blue here. This is 1/5, but the natural log of 1 is 0, so that's going to cross that out. However, don't forget I have a minus 1 to the 5th over 25, so that's going to be plus 125. And so this is gone, and I think I guess I can leave it like this. 2/5 e to the 10th minus 1/25 e to the 10th plus 1/25. Here is my answer for that. Again, everything in blue is just a substitution and subtraction. So I really don't worry about that. What I'm more concerned is, did you understand how we got to the antiderivative to begin with? Specifically, do you understand how we set up the integration by parts formula here? Because we had to select a u that I was going to take the derivative of and a dv that I was going to take the antiderivative of. And then the formula says, and I'm going to write it here in purple, u times v minus the integral of v times du. And that's exactly what I plugged in. U times v, these two, minus the integral of v, which is this, times du, which is that. That's integration by parts. It's a slick way and use of the product rule to find an antiderivative.